Given the graphs of the functions f, that's this one, and g, this one, find each function value by inspecting the graphs, then write the corresponding ordered pairs. Okay, so first we have f of 2 equals what? So remember, f of x equals y, because y is a function of x. Same thing over here with g of x. G of x equals y as well, because y is a function of x. So that's the first thing I noticed from this question, is that I'm talking about f. So I'm going to be using that first graph. And this 2 is where the x should be. So they're saying x equals 2, find y. Alright, so x equals 2. Let me go to the graph. Right here is a point on this graph, and that's where y equals 1. So f of 2 equals 1. And then I want to write the ordered pair as well. So first x, which is 2, and then y, which is 1. And that will be the ordered pair for that point. For b, we're looking at g, so we're going to be using that graph on the right. And that 0 is where x should be. So that means that x equals 0. Figure out what y is here. Alright, so x is 0 right at the origin, and actually that's where the point is on this graph. So y equals 0. Therefore, the ordered pair will be x, y, so 0, 0 for that point on that function. For c, if f of x equals 2, then x equals what? So f of x is y. So if y equals 2, then figure out what x is on the f graph. So that's this one on the left. So y equals 2. What is x? Well, there's a point there where x is 4. But if you go the other way, there's another point here where x is negative 4. Both of those are points where y equals 2. So I'm going to have two ordered pairs. The first one, x and y, so 4 and 2. And another one where x is negative 4 and y is still also 2. For d, if g of x equals 3, then x equals what? So I'm going to the graph on the right, the g, and this says y equals 3. So y equals 3 on this graph. What is x? So here's a point where y equals 3 and x is 5. But here's another point where y equals 3 and x is negative 3. So we're going to have 2 points here. One where x is 5 and y is 3. And another one where x is negative 3 and y is 3. And that can happen with nonlinear functions. You can have more than one point where x is different but y is the same. But you wouldn't have it the other way where y is the same, because that's not a function. Here we have a graph that shows total and online enrollments in post-secondary institutions as functions of time. So we want to approximate the total enrollment in fall 2007 from the graph. So total enrollment is this graph here. 2007 fall. Okay, so go up to this and we have a point. It looks like it's about 18 and it's in millions. Wow. So 18 million students approximately. Is it above the line? Let me zoom in and erase what I put there so I can see better. Is above the line? Yeah, it's above the line. So when I say 18.1 million. Come on. Okay, so we'll change that to 18.1 million students. For part B, use the function f of x equals 0.55x plus 0.3 to approximate the online enrollment in fall 2008. So let's go ahead and look at the graph for f of x, and fall 2008 is here, so we're going to zoom in a bit. And the point is right there, and that's definitely above this line. It's not quite halfway to the next line, but it's about halfway to halfway, so we're going about from 4 to 6. It's not quite 5, but I would say 4.5 then. So let's go ahead and put that 4.5, and it's in millions of students. So that's our approximation for fall 2008 there. And now we want to find the increase in enrollment from fall 2007 to fall 2008. So in 2007, we looked at the total, but now we just want to look at the online. So let's look at 2007 here. That looks like it's on the line of 4. So I'm going to say that that's 4 exactly. In fall 2007 and 2008, we said that's 4.5. So how much did it increase? We could take the difference, and that's 0.5. So 1/2 million students, or a 500,000 student increase from 2007 to 2008. And actually, if you look at the function, you'll see that the increase is 0.55, so our approximation is really, really close here.